filters, the minimum particle size that can be removed from this device, that is less than 1 micrometer. At the same time, we can say that the efficiency of these filters that is greater than 99%. Let's see in detail about this filter control device. In such system, the flue gas is allowed to pass through a woven or felted fabric, which filters out the particulate matter and allows the gas to pass. The smaller particles are retained on the fabric, initially through interception and electrostatic attraction, and later on, when a dust mat is formed, the fabric starts collecting more efficiently. A bag house, we can see at the right side of the slide, bag house filter unit provided in an ordinary room of the factory contains several vertically hanging fabric cylinder bags that size of 1.8 to 9 meter long. The number of bags can vary from few hundreds to 1,000 or more depending upon the size of the bag house. The bag house are constructed as a single or compartmental unit. The upper end of the bag are closed and lower end are attached to a hopper, where also the inlet of the flue gas drops out particulate matter in these bags, which settle down into the hopper, and cleaner gases go out from this fabric filter. The framework housing the hanging bags is provided with an automatic shaking device for cleaning the bags of the collected dust. Operational problems of this device. Various problems during the operation of bag house. First one, cleaning. At intervals, the bags get clogged up with a covering a dust particles, and the gas can no longer pass through them. At that point, the bags have to be cleaned by raping, shaking, or by reverse airflow by pulse jet. Next one is a rupture of cloth, which results from shaking. It is often difficult to locate ruptures. When they are found, the replacement time is often considerable. Then next one is temperature problem. The fabric filter will not perform properly if the gross temperature overload occurs. So we can say that if the temperature is less than 300 degrees Celsius, that is suitable temperature. Then bleeding, this is the penetration of fabric by fine particles, which is common in fabric filtration. It can occur if the wave is too open or the filter ratio is very high. The solution is to use a double layer material or a thick woven fabric. Then chemical attack. So another important problem associated with fabric filter, the possibility of chemical attack due to corrosive chemicals presence in the effluent. A proper choice of fabric filter will avoid this problem. Advantages of fabric filter are high collection efficiencies for all particle size, especially for the particles smaller than 10 micrometer in size. And the construction and operation procedure are very easy, and the nominal power consumption, and the same time the waste product or the dust product that is in dry disposal or dry state, so we can easily handle it. Disadvantages, the high maintenance and fabric replacement cost, because the bag house are difficult to maintain because of the efficiency, because of the difficulty in finding and replacing even a single leaking bag. And also general rule, about 1/4 of the bags will need replacement every year. Then the large size of equipment, and the problems in handling dust, which may abrade, corrode, and blind the cloth. These are the main disadvantages of a fabric filter. These type of devices can remove the size of particle is less than 1 micrometer. So we can use these type of devices in metrological industries, foundries, cement industries, chalk and lime paint industries, brickworks areas, and ceramic industries and floor mills, etc. Scrubbers are devices that remove the particulate matter by contacting the dirty gas stream with liquid drops. Generally, water is used as the scrubbing fluid. In a wet collector, the dust is agglomerated or collected with water and then separated from the gas together with the water. The mechanism of particulate collection and removal by a scrubber can be described as a 4-step process. The mechanism of this scrubber that can be described as a 4-step process. First one is transport. The particle must be transported to the vicinity of the water droplets, which are usually 10 to 1000 times larger. Then the collision process, in that the particles must collide with the droplet. Then adhesion, that is promoted by the surface tension property. And the last one, that is precipitation. This involves the removal of droplets containing the dust particles from the gas phase. The physical principles involved in the operation of the scrubbers are impingement, interception, diffusion, and condensation. Impingement means when gas containing dust is swept through an area containing liquid droplets, the dust particles will impinge upon droplets, and if they adhere, they will be collected by them. If the liquid droplet is approximately 100 to 300 times bigger than the dust particles, the collection efficiency of the particle is more because the numbers of elastic collision increase. Interception, that is particles that move with the gas stream, may not impinge on the droplet but can be captured because they brush against the droplet. This is known as interception. Then diffusion. Diffusion of particulate matter on the liquid medium helps in the removal of particulate matter. Condensation of the liquid medium on the particulate matter increases the size and weight of particles. This helps in easy removal of particles. In this device, the flue gas or this contaminated gas enters into the scrubber and made to push up against a downfalling water current. The particulate matter mixes up with the water droplets and thus falls down and gets removed. The water solutions, when replaced with other aqueous chemical solutions like lime, potassium carbonate, slurry of magnesium oxide, or etc., do help in removing gases pollutants also from the contaminated gas. The various types of scrubbers are available: spray tower, venturi scrubber, cyclone scrubber, packed scrubber, etc. The spray tower and venturi scrubber can be made to remove gases pollutants along with removing particulate matter. The spray tower can remove the size of particle is greater than 10 micrometer, and venturi scrubber can remove the size of particle is greater than 0.5 micrometer. These are the cyclone scrubber and packed bed or packed scrubber figures. Advantages are: the scrubber's initial cost is very less. and hot gases can be cooled down. That means it is applicable for the high temperature installations. And corrosive gases can be removed and neutralized. The separated gases through the contact with the aqueous chemicals may produce useful byproducts as chemicals and fertilizers, etc. The disadvantages are it requires high power for this proper working of this scrubber. At the same time, the maintenance cost is high when corrosive materials are collected, and the wet outlet gases cannot be raised high from the chimney or stack. So the same time the fume, that means the removing gases or that clean gas may sometimes be visible in sky due to the presence of water vapor. And the same time it requires a lot of waste to water usage is very high in this type of device. And another one, freezing problem may face in cold countries.